So, good morning. Thank you very much for coming. My name is David. I'm a software engineer. I'm visiting Shanghai from Sydney, where I work for VMware. I'm the tech lead on a product called Contour. It's a Kubernetes Ingress controller that uses Lyft's Envoy proxy as our data plane. So the part of Kubernetes that I spend all my time on is in this Ingress area. But perhaps you don't. Perhaps you don't live and breathe Ingress as much as I do. So I want to go over a little bit about what an Ingress controller does. Ingress controllers are responsible for bringing traffic from the outside world down to your pods. This means HTTP, TLS, load balancers, reverse proxies, all of that good stuff at layer 7. And just to be clear, even though we do use Envoy as our data plane, we're not a service mesh. It's a common misconception that says, oh, you use Envoy, you must be a service mesh. Nope. Envoy can do many, many, many things. We use it, the way we configure it is as a load balancer. So we're focused exclusively on bringing remote traffic into your cluster. And that's quite a broad topic. So the way that I've approached this design space is to say a good Ingress controller should be able to take care of 90% of the reasons that maybe previously in previous lives and previous automations you would have had to use Nginx or Apache or Squid or some kind of sidecar or some middleware or something in the request flow to augment your application, either as middleware or as kind of glue to bring it all together. So we're never going to get to 100%. Like 100% use case is impossible. It's too specialized. But I reckon there is a point, about 90%, where we can deliver through the Ingress object a lot of functionality. The big one is traffic consolidation. So if you haven't used Ingress before, you're just using service objects with type load balancer, you probably know that generally if you're inside a cloud environment, you declare a service type load balancer, your cloud provider will go and spin up an external load balancer, get a public IP, and plumb that down to your cluster IP. This obviously has a monetary cost, and of course every new component you add to your application is a maintenance cost. It's another moving part. They also consume public IPs. Where I live in APNIC, IPv4 IPs are not very scarce. And perhaps more relevant for the audience here is that your security team may not be totally okay with you having tens or perhaps hundreds of random public IPs bringing traffic into your Kubernetes cluster. You may really want all that traffic to hairpin through one place that they can analyze, they can apply DOS policies, all that good stuff on top of. And so this is one thing that Ingress controllers do. They bring all the traffic through a single hairpin. The second one is TLS management. We're halfway through 2019. You need to be talking about how to present your applications behind TLS, behind HTTPS. Now, the good news is that on the Kubernetes side, we have projects like Cert Manager and Let's Encrypt, who are going to do that work of getting a valid public certificate, renewing it, keeping it alive, for that kind of 90-day rolling window. An Ingress controller does the other half. It's going to make sure that you can present that certificate on port 4.3 so that you can secure your application via HTTPS. So there really shouldn't be any reason why in 2019 you can't have a secure application. There are no structural limitations to doing this anymore. This is certainly something that Ingress controllers help with. The third thing that I think are a big part of the Ingress controller promise is this notion of abstract configuration. Now, probably given your backgrounds, you've used every kind of load balancer from F5s through to Nginx, through to HA proxy, through to Apache, through to Squid, and all of them have different configurations. To do the same thing, to deploy the same application, you need to rewrite the configuration in whatever language that your tool uses. So Ingress provides us a way of having an abstract way of describing the properties of a web application. The different routes, how they're matched, which services they go to, in an abstract way. And the Ingress controller takes care of the specific configuration for the specific data plane that you're using. And the last one is path-based routing. So going back to the first point, if you're using a service IP with a cluster, you get TCP at layer 3 down to your pods. Not HTTP, not HTTPS, just TCP. You have to take care of running a web server to do that handshake, to that TLS handshake, to do path-based routing, all of that stuff. You have to do that in your application. And this is definitely something that an Ingress controller should take care of, as well as talking about your abstract configuration, so that you can describe the way that your web application works to Kubernetes rather than encapsulating in your application. So, with that background, what is Contour? Contour is an Ingress controller that we built back when I was working for Heptio. We're now part of VMware. And Contour exists to do these things on this slide. It exists to fulfill this promise. So with that background, I want to talk about some of the larger issues with Ingress controllers. Not specifically the one that I work on, but the one that all of us implementers work on, dealing with the Kubernetes Ingress object. So I think my biggest complaint with the Kubernetes Ingress object is that the specification for it is just a bunch of text comments in the API documentation. The entire specification for what we have to go on is in the API machinery types. It's in the comments on those types. And so JSON is not a specification. JSON is barely a schema, and it's not sufficient to describe how to implement this specification. And to make this concrete, this is literally the specification that implementers like myself have to work from. Now, this is perfectly fine if you are communicating with the API server, like you're just sending a message to the API server or using a kind of curl command line. This is perfectly fine. But as an implementer, someone who's building tools on top of this API, we never need a level of formality in this specification that is simply not present. What I think that we need is something akin to the level of detail of an internet-style RFC. Because, as we'll see as we go through this presentation, there are a lot of ambiguities in the specification. And because there are ambiguities, that breaks the promise of the Ingress object. Because it's ambiguous, you can't abstract the configuration. Because it's ambiguous, different Ingress controllers implement features in different ways, and it breaks this idea of portability. So to take an example, let's talk about the default backend. This is what the specification says for the Ingress default backend. It's a default backend capable of servicing requests that don't match any rule. This is the sum total of the specification for the default backend. So what we have is a situation where each Ingress document can have the notion of a default place to route traffic if it doesn't match anything else. Requests that don't match any rule go to the default backend. That seems pretty straightforward if you're coming from a programming point of view. Like if you have you're writing a case statement, you're going to have a default case that doesn't match anything else. But the problem with this is that it only makes sense if there was ever only one Ingress document. And that's not the case. So this idea of a catch-all backend is not to catch all the traffic on every vhost. It's something else. It's something akin to a default place that any traffic that comes to your cluster for any virtual host could potentially go for. And if it wasn't complicated enough, you can mention the default backend in every Ingress document. So which one takes precedence? And it's these kind of ambiguities which are left to the interpretation of the implementer. People like me, the Nginx Ingress controller, traffic, ambassador, everyone implementing the spec, we have to use a lot of our imagination, because you saw the specification is very, very thin here. It doesn't tell us what to do. The default backend conflates the notion of a virtual host, like www.microsoft.com, which is the host header that the traffic will arrive with the backend that's going to serve it on. And that doesn't make a lot of sense, because for some cases you might want the default rule to be send a 301 redirect to my main website. Like say you don't want to have www in your URL, but if requests come on that, you want to redirect them. There's no way to do that in the Ingress spec. There's no way to do that with the default backend. It gets kind of weirder. Each rule has a host key, but that host key is optional. So does that mean that this rule matches the traffic arriving on any virtual host? It's kind of weird. Ingress ceases to be about these are the routes within a virtual host and becomes these are just a pool of routes. And as I said, the default backend can be present in multiple Ingress objects, as well as this very loosely specified idea of a global default backend, which is completely not defined in the specification. It exists only in the man page for kubectl. So the question of if the default is specified multiple times, which one takes precedence? So, speaking of namespaces, the Ingress spec permits a virtual host to span more than one Ingress object. In fact, this is very, very common. And this means that the definition of a virtual host, the routes for my www.example.com, can span multiple namespaces. I mean, you can see the argument for why it works like this. Ingress objects can only refer to the services in the namespace they're in. So if you want to build an application out of services from Team A and Team B and Team C and put them all on routes within the same virtual host, you need to have an Ingress object in each of those namespaces sharing the same virtual host so that they're all brought together. This seems pretty logical. Like if you had the finance department in one group, in one namespace, and the ads department in another namespace, that they all collaborate to the same website, you would have an Ingress document mentioning the same website across all of them, and the Ingress controller will stitch them together. However, this means that if someone has RBAC permission to write an Ingress object anywhere in your cluster, they can add a route onto any virtual host serviced by that cluster. There is no way to namespace, to use RBAC to say, you can only write Ingress objects for virtual host A, but not B. So anyone in your cluster with the permission to write an Ingress record can add a route to your virtual host, even though they never had permission to write into your namespace. And just in case you're thinking, this sounds like a terrible security hole. Maybe I'd like to not do that. You cannot. Because in a perfect example of Hiram's law, which is the idea that programs will evolve for any observable behavior, projects like Cert Manager rely on this ability. The way that Cert Manager answers the HTTP 1.0 challenge is it edits its Ingress record in its namespace to project /.wellknown into your Ingress. And this is how the product works. We can't disable this feature unless you want to disable helpers like Cert Manager. What this boils down to is that Ingress is very difficult to use in a shared cluster. There are no safeguards to prevent anybody that has the permission to add or edit Ingress records from accidentally, or perhaps maliciously, depending on what kind of cluster you're running, messing up somebody else's Ingress. This is just not possible. Let's talk about a few other problems before we get to the solution. Let's talk about a few other problems. And this is more focusing on modern web application patterns. Kubernetes services are mapped onto HTTP routes via an Ingress document. However, the Ingress spec only permits us to have one service per route. So / prefix goes to that service, and only to that service. Now, a service can match multiple pods. We can do that if they all have the same label. So we can, and the endpoint controller will, if all pods share the same label, will mix them together into the same endpoint. But it's going to be basically a weighted assignment. If you have 5 from deployment A and 5 from deployment B, you get roughly 50-50. So if you wanted to do something like a canary deployment, you wanted to send 1% of your traffic to the new version of your application, just 1%. To make this work in this scheme, you would have to have 99 pods of the old version and 1 pod of the new version. That's pretty unrealistic. So even doing simple patterns like canary deployments and blue-green deployments are very difficult with the Ingress spec. Anybody else who's worked with Ingress knows that most of the configuration for an Ingress object is not actually in the YAML, it's in annotations. This has led to, because of the limitations in the Ingress object, because there are so few fields, we have to put everything in annotations. Common things like, do you allow port 80, or do you put a 301 upgrade in an annotation? Request timeouts, retry parameters, all these things must go into annotations. And if that isn't bad enough, because the configuration for a virtual host spans multiple Ingress documents, and annotations are only present on a single Ingress document, there are a lot of questions about how does that annotation apply? For example, 301 upgrade settings, request timeouts, retry parameters. If you wanted to have some routes have a long retry parameter and some have a short, logically you would put the routes with the short retry parameter into one Ingress document with short timeouts and create a second Ingress document for the same virtual host for the routes with the longer timeout. So arguably, the annotations apply to the things mentioned in that document, not to the virtual host. But this argument breaks down when we talk about properties that apply to the virtual host itself. Like, for example, what is the minimum TLS version that this website will accept? Say your company has a policy, you only accept TLS 1.1 or higher. So that means, how are we supposed to interpret this annotation? If you split your host across several documents and they have different values for the TLS min protocol version, that means that you've committed to doing a different TLS handshake based on the path of the request, which you don't know at that point because you haven't completed the TLS handshake. So it seems that some annotations apply on the Ingress and some apply globally or to the virtual host. But if that were true, then that means I could change the TLS version of your website by standing up in Ingress, mentioning your website's virtual host with my own annotation, either conflicting with it, upgrading it, downgrading it. This is a problem that has no solutions. It's not soluble because the specification that Ingress came from didn't consider how this would work. Okay, so this is a good time for me to pause to say that while I have a bunch of gripes about Ingress, they come from my position as an implementer, somebody who has to answer all these questions in code. Like I can't defer to the documentation, I can't ring someone for support. I have to answer all of these questions because this is software. It must know absolutely any time. But what I don't want you to come away from this talk is saying, well, this guy from Australia said, Ingress is no good, we can't use it. Ingress isn't broken. It's just a little bit limited. And if you're not hitting those limitations in your scenarios, in your clusters, they're far from it being, for me, to tell you you're doing something wrong. But if you are experiencing these problems, like you've been through some of these discussions, you've had these questions, let me tell you about what we're doing in Pronto. About a year ago, what was still called Heptio, we started a joint development agreement with Yahoo Japan to build a large load balancing solution for them using a Kubernetes cluster effectively like an appliance. Now, Yahoo Japan had experienced almost all of these problems, not through malicious intent, but just accidentally messing up other people's routes by fat fingering and copy pasting things in error. They had experienced all the problems in trying to use Ingress in a multi-tenant solution. So we went away and we came up with a different design in the CRD called IngressRoute. Now, the first thing that we changed was that each IngressRoute document refers to one hostname and one hostname only. There is exactly, in your cluster, there is exactly only one document that describes the properties of a host. Here, spec, virtual host, the name of the virtual host, blog.heptio.com. And because now we can define one place to talk about virtual host things, not routes, we can put the TLS parameters in there. We can put other information about the virtual host, not about its routes. And there's one place that they go. And for reasons that I'll explain in a little bit, we call this a root IngressRoute document because as we'll see, they are at the root of a tree. And so anytime you see a spec with a virtual host, this is the root of a configuration for a virtual host. Now, because we're no longer limited to the schema that Kubernetes gives us in the Ingress object, we have a place to put all that configuration that was previously stuffed into annotations. For example, per route, per service on that route, we can control things like the load balancing strategy. So, matching route for blogs, one backend service, it's called the blog service, and the strategy we're going to use to load balance across the different pods that make up that service is weighted least request. One of the other reasons we chose Envoy is it has very, very good configuration reload support. There is no kind of process stopping, being restarted, delays, like reloading the process. We stream configuration changes to Envoy straight away and they're applied straight away. This means that we can do things like long-running WebSockets without dropping connections. And so if you want to enable WebSockets, it's not an annotation, it's just a thing simply there. Now, in general, when there is a feature that should be available for all users, we generally like to turn it on for everybody. So for example, you will not find a configuration for compression because we just turn that on for everybody. I can't think of a reason why you would not want to improve your latency and save bandwidth by compressing the result. But for WebSockets, it's a little bit more complicated because if we allowed any route to be upgraded, potentially that allows a malicious attacker to send a WebSocket upgrade when the application isn't expecting it. So in some specific cases, you have to opt in for these features. But as you see, it's very straightforward. It's right there in the YAML. Another common feature, which is very commonly stuffed into annotations, are timeouts and retries. So in this example, we have both a timeout policy, which is 1 second from the start to the end of the request. You might want them short, you might want them long, but you certainly usually want to have some kind of timeout so that connections don't stay open indefinitely. And depending on the stability of your application or the way it deals with overloaders, you might want to have retry. You might want to say, try 3 times, giving each try 150 milliseconds. So again, you see, we can just put these right there in the YAML without having to have any confusing annotations. The Kubernetes Ingress document limits routes to a single backend service. But because we define our own CIT, we can change the rules. In this example, we have 2 services. So there's going to be roughly equal weighting between those. So rather than creating a service, creating 2 pods with matching labels so they were all merged into the same service, we can now talk specifically about 2 different services that serve traffic for Slash. Why would you want to do this? Why is this important? Well, the main reason you wanted to have more than one backend is to do things like a canary deploy or blue-green deployments. So in this example, this is a totally made-up product. I think it's some mail service. Now, 90% of the traffic is going to version 1.3.1. 10% of the traffic is going to version 2. So this is how you could do a blue-green style deployment. Maybe you start at 1%, you go to 10%, you go to 50%. And so over time, the amount of traffic being served by the old version, the amount of traffic moves to the amount of traffic served by the new version as you gain confidence that things are working out. And you can change these numbers on the fly. You just edit this document, Control Edit, and those changes are applied immediately. There's no restarting, there's no reloading the process, there's no drop connections while the configuration is reloaded. This happens in real time. So there are 2 things to go. One is delegation. Delegation is our answer to helping multi-tenant clusters stay manageable. All the IngressRoute documents you've seen so far are what we call routes. And that is because they're at the root of a tree of delegation. And to explain why delegation I think is important, we'll have another example. So again, this is a totally made-up company. And so you are the Kubernetes administrator. These are the problems that you've been asked to solve. You want to delegate control for the finance route, /finance, to the Google Finance developers who are working there over and there in the Google Finance namespace. So any traffic for finance and below should be going to the applications in the Google Finance namespace. Importantly, this Google Finance team shouldn't be able to alter the configuration for any of the other properties on this website. They shouldn't be able to touch ads, touch search, touch the homepage. They should only be able to work in their little area called /finance. And most importantly, none of the teams working on contributing parts of this application should actually have access to things like the TLS secret for serving www.google.com. So how would you do this with the Kubernetes Ingress object itself? You could certainly split your routes across various namespaces. You could put the /finance match over an Ingress document for the Google Finance namespace. But as I've laid out today, it is difficult to do that securely. It is difficult to do that knowing that you have properly locked down this configuration. It's difficult to know that you have made sure that nobody else can overwrite or add routes. You have to control the people who can use this cluster very closely, even though you've deployed RBAC and you've put people in namespaces. So here's how we would do it with our IngressRoute document. We can see this is a route. It has a virtual host stanza. It's in the Google.com namespace. There's the secret in there, so it lives in the Google.com namespace. Unless you have permission to read that namespace, you can't read that secret. And now down here, we have the standard matches that you've seen previously. We have this new stanza. Rather than service, we say delegate. And you can think of delegation at this level kind of like file include. We're saying, okay, go and include the search document in the Google Search namespace, and go and include the finance document in the Google Finance namespace. So you can think about it like inclusion. Here's the finance document, so the Google Finance namespace, and it has information about who's servicing /finance. it doesn't have a virtual host stanza. This doesn't mention anything about the host it applies to. It is what we call, it's not a root, it's a child resource. This configuration can only be referenced by somebody else. So you can write whatever documents you want, but unless there's a reference to it from another document, it's meaningless. That configuration is not connected to anything. So one of the ways you could think about it is the way that DNS works. You delegate part of your namespace to a different name server. And that gives you, as the person that controls the top level domain, the ability to say, I bless them with having the configuration. I delegate to them the configuration. And the final piece of this multi-tenant puzzle is the ability to restrict where we will look for these root namespaces. As an opt-in feature, you can say to Contour on startup, only look in these specific namespaces for root ingress documents. So we'll only start building this tree based from the documents that you permit. Obviously, they would be in some administrator's namespace. So the administrator, just like the Google example, would set up the configuration for google.com. They would control the certificate, and they would delegate the actual routes, like the routes for the application, to different application teams in different namespaces. But this is how we can use RBAC to securely create a way to use Ingress in a multi-tenant cluster. So that's all I have to show you today. You can come check us out at github.com hepgeocontour. You can find us at hashcontour on the Kubernetes Slack. And of course, you can email me anytime you like, or send me an issue on GitHub. We have a lot more information on there, including documentation about the IngressRoute CRD, how it works, all the different options, and many more than I've shown you. And I think I have maybe 2-3 minutes for questions. So if there are any questions, just put your hand up. I'll give the microphone out. Do you have the microphone? Okay. The gentleman at the back with his hand up, and then you.
Thanks for a great presentation.
Thank you.
So as you mentioned, because of the limitation of the Kubernetes Ingress CRD, so different open source projects are using different approach, like annotation or custom CRD for their configuration of the Ingress controller. So, I mean, what do you think is the right way going forward for the Kubernetes Ingress? Are you going to push, maybe contribute this to the upstream project like Kubernetes?
I kind of knew you would ask this question. So this question comes in two forms. It's, are we going to contribute upstream? Or if you saw the videos from KubeCon about a month ago, what about the Ingress V2 that Bowie and Google has announced? The answer is somewhere in the middle. We have customers who need this service right now. So we have built this for our customers. They're using it. You can come to VMware and ask for support on this. This is a fully supported product. But as you say, at the moment, each of the Ingress controllers is doing something different. That's terrible for the community. We would really like some consolidation. However, I think those discussions of consolidation are still quite early. The Ingress V2 stuff that Google talked about a month ago, I still haven't seen a KEP for. But I think the easiest way is that we're on SIG Network. We're really looking to contribute when the discussion starts. We are really ready. Like, if you're watching this video, please come and talk to us. We really want to talk. Do we have time for one question? I think it's this gentleman here. I got to get out of here.
Okay, thank you. My question is, what's the distinct advantage compared with the other Ingress controllers such as GFK, Nginx, and Cone, and some others?
Okay, so how do we compare to other Ingress controllers? Almost all the Ingress controllers differ by their choice of what they use for their data plane. So we use Envoy, Nginx, obviously GCK uses the GLB load balancer. In terms of why would you choose, if you weren't interested in this IngressRoute stuff, why would you choose Envoy over a different one of those. And I would say that the reason is not perhaps for performance or any of those things. I think almost any Ingress controller can saturate a network these days. That's not hard. The benefit that we have is Envoy has a very good reconfiguration API. You stream configuration via gRPC. It's not writing a file and then reloading the process. We can stream configuration very, very quickly, so we can make those changes effectively immediately. And that, certainly from my history as an operator trying to debug Ingress problems, it is a huge benefit when you know that if the configuration isn't working how you thought, it is because you made a mistake, not you didn't wait long enough. Okay, so I'm out of time. Thank you so much. Thank you for the next speaker for your patience. Thank you very much.